morning, dear students. I am Miss NAVEDA SHIAKH from Brahan Mumbai Mahanagar Palika MCGM virtual class. I welcome all my dear students to another and interesting session. In today's session, we'll be learning something new and interesting from a science textbook. So let's get started.
Good morning, dear students. I am Miss NAVEDA SHIAKH from MCGM virtual class. I welcome all my dear students to another and interesting session. Today we have standard 8 science with us. Today's topic is the continuation of the topic that we've already started last week, that is inside an atom. Now this week we'll be continuing with the remaining half of the chapter, and if you haven't seen the video, please go to the channel and see the first part of the chapter so the concept becomes much clearer to you. So let's get started. Now, distribution of electrons. Now we have learned how electrons are there, where the electrons are placed, where is the nucleus, what is there in the nucleus, that is how you have protons, electrons, neutrons placed in an atom. We also learned about how there are electronic shells also that are known as orbit are present around the nucleus, okay, and the electrons are revolving around the nucleus in those orbits. Now these electrons are the most important part in science because everything that we'll be learning will be related to the sharing and combination of the electrons. ठीक है, किस तरीके से electrons move होते हैं और किस तरीके से एक bond बनाते हैं, इससे related हर चीज होती है. So you have to be very attentive when understanding about electrons. Now we have learned that there are electronic shells present in an atom, जिसमें electrons move होते हैं. So as per Bohr's atomic model, electrons are revolving in a stable shell. These shells have a definite energy. हर एक शेल की, हर एक जो सर्कल आप लोग को दिखाई दे रहा है, हर एक शेल का एक पर्टिकुलर एनर्जी लेवल पे होता है. The shell nearest to the nucleus is called the first shell. Now if you look at the picture, center में nucleus है जिसमें protons और neutrons present है. Outside that, if the first shell that you see, the first ring that you see, it is the first shell. After that, the second ring that you see is the second shell. Now the symbol n is used for the ordinal number of a shell. मीन्स वो n1, n2, n3, वो हम लोग को n जो है वो हम लोग को बताता है कि हम लोग कौन से नंबर ऑफ शेल की बात कर रहे हैं. ठीक है, इफ सपोज इफ इट मेंशन n1 मीन्स न्यूक्लियस के बाद फर्स्ट जो शेल है उसके बारे में बात हो रही है. सो दैट विल गिव यू एन आइडिया. द शेल्स आर रेफर्ड टू बाय द सिंबल कैपिटल K, L, M and N corresponding to the ordinal number, that is n is equal to 1, 2, 3, 4. So N1 is K, N2 is L, N3 is M and 4 is N and so on. The maximum number of electrons a shell can contain is obtained by the formula 2n square. Okay? So this formula is important and note down this if you wish to. As the magnitude of n increases, the energy of an electron in that shell increases. जैसे जैसे हम लोग हमारे सेंटर से दूर जाते हैं वैसे वैसे नंबर ऑफ इलेक्ट्रॉन्स भी इंक्रीज होते जाते हैं और एनर्जी लेवल भी बढ़ता जाता है. ठीक है, सो आई होप द डिस्ट्रीब्यूशन ऑफ इलेक्ट्रॉन्स इज क्लियर टू यू ऑल. व्हाट इज द मीनिंग ऑफ शेल, हाउ दे आर अरेंज्ड, हाउ द इलेक्ट्रॉन्स आर अरेंज्ड, दैट वी विल बी स्टडी. नाउ के, जो के है हमारा जो पहला रिंग है, जो पहला शेल है, it has the power to accommodate 2 electrons in it, okay, whereas L can accommodate 8 electrons in it, M can accommodate 18 and N can accommodate 32 electrons in it. Okay, so you have to remember these things. Now next, a very important thing, that is electronic configuration of elements. Now when I talk about elements, you have already learned about how the electrons are accommodated in the shell, that is K, L, M, N respectively. Now remember that how the shell is arranged around the nucleus, उसके अंदर किस तरीके से electrons distribute हुए हैं atom के अंदर, उसे कहते हैं electronic configuration of the element. ठीक है, so here The shell-wise distribution of the electrons in an atom of an element is called the electronic configuration of the element. Now, if you notice at the two examples that I've taken, sodium and argon, इसके अंदर sodium has 11 electrons present and argon has 18. Now, how are we going to arrange it? We will start from K. पहले हम लोग 2 लिखेंगे, 2 electrons mark करेंगे K में, ठीक है? उसके बाद we have the second shell, that is L, which will accommodate how many? It will accommodate 8. So 2 already यहाँ mark कर दिए थे, 8 बाहर लिखेंगे, तो 2 और 8 हो गए 10, अब बचा 1. तो जो लास्ट रिंग है, थर्ड रिंग है हमारा, शेल है जो, उसमें कितने इलेक्ट्रॉन्स आएंगे सोडियम में? 1. When we move on to argon, now argon has 18 electrons. So 18 electrons रहेंगे, तो again we will have 3 shells over there. The first shell will have 2 electrons. The second shell, that is L, will have 8 electrons. अब ये 2 और 8 कितने हो गए हैं? 10. अब remaining how many are left? Again 8. The third shell can accommodate 18 electrons. ठीक है? But argon के पास अभी कितने free बचे हैं? 8 ही बचे हैं. तो last का जो shell है उसमें 8 accommodate हो जाएगा. Okay? So this is how the electrons are arranged in the shells. Each electron has a definite energy as per the shell in which it is present. Energy of an electron in the first shell, that is K, is the lowest. As I told you, it has only 2 electrons in it. Energy of electrons in the subsequent shells goes on increasing with the ordinal number of the shell. जैसे जैसे number of shells बढ़ते जाते हैं वैसे वैसे उसका energy level भी बढ़ता जाता है. The electronic configuration of an element is such that the energy of the electrons together is the maximum possible. ठीक है? So electrons जो हमारे place होते हैं shells में, उसकी capacity और with the maximum capacity of the electronic shell in an atom and the increasing order of energy. जैसे जैसे हमारा ये याद रखेंगे, इलेक्ट्रॉनिक जो हमारे इलेक्ट्रॉन्स जो शेल में मूव हो रहे हैं, जो सबसे नियर होगा न्यूक्लियस के, it will have less amount of energy as compared to the further ones. जो दूर है उसके अंदर इलेक्ट्रॉन्स रखने की कैपेसिटी भी ज़्यादा है और उसका एनर्जी लेवल भी ज़्यादा होता है. ठीक है? So it has maximum capacity according to the electronic shell. कौन से शेल के बारे में बात हो रही है? ठीक है? So if you remember this two example, it will be clear to you all, and you can try and solve few more examples that are there in the textbook. The electronic configuration in the numerical form contains numbers separated by commas. Now here you can see how it is written along with the diagram that you can draw. ठीक है? सोडियम में कितने होते हैं? First shell में there are 2, second में you have 8, and the third one has 1. So altogether you have 9 electrons, right? So how are we going to write it numerically? ये तो हम लोग ने एक रिप्रेजेंटेटिव फॉर्म में हम लोग अगर डायग्राम फॉर्म में बनाएंगे तो इस तरीके से बनाएंगे, बट अगर हम लोग को न्यूमेरिकल फॉर्म में लिखना है तो यू विल राइट इट, देन यू विल राइट द नंबर्स अकॉर्डिंग टू द शेल्स, कितने इलेक्ट्रॉन्स हर शेल में है, सेपरेटेड विद द हेल्प ऑफ द कॉमा. The first shell has 2 electrons, then you will put a comma, then you will go on to the next shell, that is L. You will count how many electrons are there. There were 8, so I've written 8. Then you will mark again a comma और हम लोग थर्ड शेल में जाते हैं, उसमें कितने इलेक्ट्रॉन्स हैं? 1. So I write down 1. If I go on to potassium, here I can write it as 2. First shell has 2 electrons, second one has 8, third one has 8, and the last one has 1. Okay, so like that. So here the numbers indicate the electrons number in the shell with increasing order of energy. For example, the electronic configuration of sodium is 281. It means that the total 11 electrons in sodium are distributed as 2 in the shell K, 8 in the shell L, and 1 in the shell M. The electronic configuration of atom can also be represented by shell diagrams. So these two things are correct. You can either represent it like this or that way. Okay, so shell diagram अगर पूछा गया तो you have to make a shell diagram and show how the electrons are arranged in each of the shell. If it is asking you the numerical form, then you can write down in this particular form and show how it is written. Okay, सो आई होप बोथ द कॉन्सेप्ट्स आर क्लियर. शेल डायग्राम किस तरीके से ड्रॉ करते हैं और किस तरीके से उसके अंदर इलेक्ट्रॉन्स अरेंज करेंगे, एंड यू कैन ऑल्सो सी हाउ you can write down in the numerical form as well. Now, what is the electronic configuration of potassium? Let's take one example in order to understand that. Potassium has 19 electrons. Okay. So the shell number we will arrange 1, 2, 3, 4. ये n है हमारा. ठीक है. I've explained your ordinal number n. The maximum number of electrons in each shell that it can accommodate. First shell में 2 होते हैं. Second shell में 8. Third shell में 18. Okay. 8 then 10. It will go like that. And the fourth shell has 32. The number of electrons of potassium, first we will arrange 2, then 8. As I told you, you have to remember how many electrons are there. इसमें सिर्फ plus minus का ही खेल है. Okay, there is nothing much you have to think about. First 2, then 8. It becomes 10. Then third वाले में 8 accommodate कर सकते हैं, so you will write down 8. And the fourth one can accommodate 1. So you write down 1. Okay, it can accommodate 32, but हमारे पास एक ही बचा है तो हम लोग एक लिख देंगे वहाँ पर. When writing the electronic configuration, the symbol of element is written first, followed by the number of electrons. Each shell separated by commas. Like example is potassium का symbol है K. ठीक है? So K लिखेंगे, bracket डालेंगे, उसकी electronic configuration लिखेंगे, that is 2881. Okay. I hope this is clear. इलेक्ट्रॉनिक कॉन्फ़िगरेशन किसे कहते हैं, किस तरीके से अरेंज होते हैं इलेक्ट्रॉन्स और किस तरीके से उसे न्यूमेरिकली लिखा जाता है. I hope this is clear to you all. Now in our previous standard we have learned how there are bonds which are there between the atoms in order to form compounds, right? We have learned about sodium chloride, what is how water molecules are formed by the combination of hydrogen and oxygen, right? तो उसमें क्या होता है, जो इलेक्ट्रॉन्स होते हैं वो शेयर होते हैं या फिर they give or they take. Okay, so that is what we are going to study in detail in this part. Now here you can see there are two examples, sodium and chlorine, and you can see sodium and chlorine. इसमें क्या हो रहा है, sodium has 1 electron in the outermost orbit, whereas chlorine has 7. ठीक है, तो ये लोग क्या करते हैं, sodium gives 1 electron to chlorine and chlorine takes 1. So that way they both become stable. Same way sodium is giving 1 electron to chlorine and chlorine takes in 1 and they both become stable. उनका जो आउटर मोस्ट ऑर्बिट है ना, जो आउटर मोस्ट शेल है, उसे स्टेबल होना जरूरी होता है. ठीक है, वो स्टेबल कैसे होगा, या तो लास्ट में उसके जो हम लोग ने टेबल पढ़े हैं ना कि के में कितना होने चाहिए, 2 होने चाहिए, उसके बाद 8 होने चाहिए, उसके बाद 18 होने चाहिए. तो अगर फर्स्ट अगर शेल की बात करते हैं, फॉर एग्जाम्पल योर helium has how many electrons? It has 2 electrons. That means it is stable. It does not need more electrons. It will not share, it will not take. Okay. Next we have sodium. The electronic configuration is 281. So now sodium has 1 electron in the outermost orbit. ठीक है, तो वो जो एक इलेक्ट्रॉन है, it makes sodium unstable. ठीक है, तो वो क्या करता है, सोडियम कोशिश करेगा to give out 1 electron to some element or some atom which needs 1 electron. Okay, understood? So that is the way electrons are being shared or given or taken from each other. Next we have neon. Neon has electronic configuration is 2-8. ठीक है, so again फर्स्ट ऑर्बिट भी स्टेबल है, सेकेंड शेल भी स्टेबल है, उसे ना चाहिए ना वो लेगा ना वो देगा. नेक्स्ट वी हैव कार्बन. कार्बन हैज इलेक्ट्रॉनिक कॉन्फ़िगरेशन एज 6. ठीक है, तो इट विल बी 2 and then 4. Here remember कार्बन मोस्टली शेयर्स इलेक्ट्रॉन्स. ओके, मतलब 2 कार्बन एटम्स एक दूसरे को कंबाइन होंगे और शेयर करेंगे एक दूसरे से. ये लोग को 4 देना या 4 लेना, it becomes difficult, so they try to make bonds with each other. Next you have hydrogen. Suppose now hydrogen is there and it has only one electron in the outermost orbit. So it tends to combine with some or the other element. Okay. The concept regarding valency of an element, chemical bonds and compounds get clarified from the electronic configuration. As I told you कि electronic configuration अगर आपको आ जाएगा तो आप लोग को valency भी समझ में आ जाएगी. Atoms form chemical bonds by using electrons of its outermost shell. ठीक है, जो outermost shell के जो electrons होंगे उसी की मदद से valency पता चलती है हम लोगों को. So valency of an atom is determined by configuration of its outermost shell. Therefore, the outermost shell is called valence shell. जो outermost shell आप लोगों को दिखाई दे रहा है उसे कहते हैं valence shell, और उसके अंदर जो electrons move हो रहे हैं उसे हम लोग कहते हैं valence electrons. ठीक है, अब वो depend करता है कि वो share करेगा या फिर it will give out electron or it will take an electron depending upon the valence electrons. कितने valence electrons valence shell में present है. Here in the first example you can see there is hydrogen, there are two hydrogen and you have one oxygen. Oxygen requires two more electrons to complete its octet state, ठीक है, to make itself stable. And hydrogen, both hydrogen has one. So in order to have two electrons in hydrogen, in order to make hydrogen stable, वो क्या करते हैं, they go and share their one electron with the oxygen valence shell. ठीक है, तो ये दोनों हाइड्रोजन ऑक्सीजन के वैलेंस शेल से कंबाइन करेंगे और वो लोग स्टेबल हो जाएंगे और ऑक्सीजन भी स्टेबल हो जाएगा. ऑक्सीजन इज गेटिंग ऑल टुगेदर 8 इलेक्ट्रॉन्स. हाइड्रोजन ईच ऑफ द इलेक्ट्रॉन्स हैज they are getting 2 each in their outermost shell. तो ये इस तरीके से both are getting balanced. ठीक है, both are getting becoming stable. So therefore the outermost shell is called valence shell. You have to remember this, and valence electrons. I hope the meaning of valence electrons and valence shell is clear to all my students. Next is valency. Now capacity of an atom to give, accept or share electrons to achieve the octet state. Now what is the meaning of octet state? I am repeating it again and again. हर एटम को बाहर का जो उसका शेल होता है, जिस तरीके से हम लोग ने पढ़ा है ना कि K में 2 होने चाहिए, L में 8 होने चाहिए, ठीक है, it has to be complete. If it is not that number, then it will either give electron, depending अगर 4 से कम है, if it is less than 4 electrons in the outermost shell, they will give their electrons. If it is more than 4, they will accept electrons. And if it is 4, okay, so they will tend to share electrons to achieve the octet state. ठीक है, for example, hydrogen has one valency, that is, it has 1 electrons in the outermost shell, valence shell, and oxygen has 6. I'm again repeating. So that way, hydrogen can give 1. Oxygen cannot give 6, but hydrogen can easily give out 1, right, in order to combine and become stable. ठीक है, तो हाइड्रोजन एक दे नहीं देता है, they combine with oxygen and in order to become stable, both will become stable. Okay, so valency समझ में आ गई, the capacity of an atom to give, accept or share electrons to achieve the octet. Now there are certain elements which are very special, like helium, neon, argon, krypton, xenon. Now these elements are called as inert gases. Okay, now why are they very special? If you look at these electrons, if you look at these elements like helium, helium के electronic जो valence shell है, it has complete octet state. ठीक है, उसे और electrons की जरूरत नहीं है, ना लेने की ना देने की या share करने की. Same way if you look at neon also, it has electronic configuration as 10. That is, it will be having, how it will be distributed, 2,8. So first में भी balance है, second shell में भी, that is L में भी, it is properly complete and it has achieved its octet state. ठीक है, तो ये लोग ज्यादा interact नहीं करते किसी और element के साथ. ना जैसे हम लोगों ने previously देखे, hydrogen keeps on reacting with some or the other element because it is not stable. Okay, it is not having a complete octet state. तो वो या तो share करेगा या तो वो देगा या तो वो लेगा. ठीक है. So there will be something or the other going on in those type of elements. Whereas when you talk about elements like helium or neon, they are chemically inert. These elements are chemically inert because they do not combine with any other atom. It means that their valency is 0. Helium atom contains 2 electrons which are accommodated in the first shell. Okay, so that is why these elements which have naturally they have a complete octet state, they are called as inert gases or inert elements, or they are also called as zero group elements in the periodic table. Okay, understood why are they called this? Because they have already achieved their octet state. They neither react with any other element, or they do not give, they do not take, they do not share. So they are chemically inert.
Valency. Let's observe the distribution of electrons in the given elements. Electrons in an atom are arranged in definite shells. The electrons which are present in the outermost shell of an atom are called valence electrons. From the octet rule, an outermost shell of an atom can accommodate 8 electrons. It was observed and concluded that an atom with completely filled subshells are stable and do not react easily. In other words, it means that the combining capacities are 0 or nil. The outermost shell of inert gas elements whose subshells are completely filled are stable. For example, helium and neon, where helium has 2 electrons in its outermost shell and all other inert gas elements have 8 electrons. The combining capacity of the atom to form molecules either with the same or different elements is defined as valency. For example, elements like hydrogen, lithium, and sodium atoms contain 1 electron in the outermost shell. Therefore, they can lose 1 electron. So their valency is 1. If atom contains less than 4 electrons in its outermost shell, the valency of an atom is equal to the number of electrons present in the valence shell. For example, aluminium has 3 electrons in its outermost shell, so the valency of aluminium is 3. On the other hand, if the outer shell has more than 4 electrons, the valency is 8 minus the number of electrons in the outer shell. For example, chlorine atom has 7 electrons in the outermost shell. Here, in this case, it is easier for chlorine to gain 1 electron instead of losing 7 electrons. Hence, its valency is determined by subtracting 7 electrons from the octet, which gives the valency of 1 for chlorine. In this module, you have learnt that electrons in an atom are arranged in definite shells. The electrons which are present in the outermost shell of an atom are called valence electrons. An atom with completely filled subshells are stable and do not react easily. The outermost shell of inert gas elements is stable. The combining capacity of the atoms to form molecules, either with same or different elements, is called valency. The valency of an atom is equal to the number of electrons present.
Next is a very interesting thing, that is isotopes. Now, we have learned that every element has a proper distribution of protons and electrons and neutrons in its structure. Okay? Now the number of protons and neutrons are always, mostly they are same, protons and neutrons in the nucleus. But there are certain elements which have a slight different thing going on in there. Now let's see what actually different is happening over here. The atomic number is a fundamental property of an element and its chemical identity. I've explained you all about atomic number. Okay? That is the number of protons present in an atom. Atomic number किसे कहते हैं? The number of protons present in a atom. ठीक है? So if you remember that, you will understand what is coming ahead. Some elements in nature have atoms with same atomic number but different mass number. अब ये mass number भी हम लोग ने पहले last period में पढ़ चुके हैं. If you do not remember, please go through the video again and you will understand what is mass number. So mass number means the number of protons and the number of neutrons. When you add them, you get the atomic mass number of that element or the atom. Such atom of the same element, like if I'm talking about carbon, ठीक है, दो कार्बन के एटम्स हैं मेरे पास, बट ये दोनों के मास नंबर्स डिफरेंट होंगे. Now how is that possible? You can imagine having two carbon atoms. One has mass number 12 and other has mass number 13. Now this happens in nature. Okay, तो ये दोनों सेम ही एटम्स हैं बट their mass number is different. So they are called as isotopes. ऐसे बहुत सारे atoms present हैं which are actually called as isotopes. I'll be explaining you all that also. For example, carbon has three isotopes, namely C12, C13 and C14. Okay, so carbon has two isotopes like C12 and C13. Both show the same chemical properties because they have the same atomic number, that is 6. Protons same है उनके अंदर, but the mass number of C13 is larger than the mass number of C12 because C13 has one more neutrons present in it. Okay, and that is why they are called as isotopes. Now this is an isotope of oxygen and this is the three isotopes of hydrogen. Okay, they are called as protium, deuterium and tritium. Alright, next let's understand more about isotopes with this video.
For instance, here's an example of a carbon atom in its most common form. Notice that it has 6 protons and 6 neutrons in its nucleus. The fact that it has 6 protons is what makes it an atom of carbon. However, the number of neutrons can vary between individual carbon atoms. These variations are called isotopes. Isotopes are atoms of the same element that differ only in the number of neutrons present in the nucleus. Here's one example of a carbon isotope, carbon-13. Notice that while the number of protons in carbon-13 remains at 6, the number of neutrons has increased from 6 to 7. This gives the carbon atom a slightly higher atomic mass than carbon-12, but chemically, carbon-13 still behaves in the same manner as carbon-12. Another carbon isotope is carbon-14. Carbon-14 has the characteristic 6 protons found in all carbon atoms, but in this case it has 8 neutrons. In some cases, isotopes may be unstable or radioactive. Radioactive atoms emit energy or subatomic particles in order to return to a stable state. This is the case with carbon-14. Radioactive carbon-14 has a number of applications in science. Since carbon is found in all living organisms and the decay rate is well documented, we can use carbon-14 as a way of dating how old a sample of tissue may be by comparing ratios of carbon-12 and carbon-14. Carbon-14 dating is commonly used in forensic studies and in studying archaeological remains.
If you liked our session, please do not forget to subscribe to our channel so that you can share and view the videos that we had today for you. And please do not forget to hit the bell icon so that you remain updated with all the latest videos that we'll be making for our dear students. This session was quite useful to you. In the next coming period, we'll learn something new and interesting. Till then, thank you.